Okay, guys, let's move forward. All right, so in the movie, I'm gonna get
the sun was
asteroid. You got the asteroid impact.
It hit with the force of 10,000 nuclear weapons.
And then what happens? You end up getting this fire, tremendous amount of heat.
1 trillion tons of dirt and rock hurtled into the atmosphere.
And if it's hitting the ground, you end up getting a crater out of it as well.
Creating a suffocating blanket of dust the sun was powerless to penetrate for 1,000
So all that heat, fire.
years.
So where does that all come from when an asteroid impacts the Earth? Okay, guys, you know this asteroid is coming at us. In the movie, it was coming towards us at 25,000 miles per hour, right? All right, so all that kinetic energy that it's got somehow turns into heat. It's going to turn into a tremendous amount of sound, so it's going to end up creating a shock wave. So where do we get the heat from? Where do we get the fire from? The sound, the shock wave? Where do we get all those from? Okay, the reason why I'm asking that question is because we've been dealing with the conservation of mechanical energy. So conservation of mechanical energy is something that happens when gravity is doing force acting on a system. So you got to conserve force acting. So here's an uplifting experience for him. It's got to be in a relationship, and then break up. All right, so he's feeling pretty high, and it's got potential energy. Gravity takes over. So what does gravity do? Gravity is going to take that potential energy, and then it's going to turn into kinetic just before impact. All the way down to impact, mechanical energy is conserved. So what happens to the mechanical energy? What happens to mechanical energy on impact? Where did mechanical energy go? All right, so that's what we'll discuss. Remember Galileo ended up discovering inertia when he was trying to figure out the acceleration due to gravity. All right, so if gravity is the only force acting, guys, you can actually explain this easily. All right, if gravity is the only force acting, the ball is going to keep going back up the same height. The reason is because equal friction, surface friction, the only force acting is gravity. It's got potential energy, so because of gravity, potential energy is going to get converted into kinetic energy, and the kinetic energy is going to get converted back into potential energy. Okay, so what you're looking at is the conservation of the mechanical energy, because gravity is a conservative force. Okay, so we'll take a look at 3 cases. The first case is straightforward. All right, so here's Galileo's incline experiment. Okay, so you got the ball. It's going to roll down, and it's going to go back up to the same height if gravity is the only force acting on it. Okay, so this will be the same as the conservation of energy. Here's the initial mechanical energy. Here's the final mechanical energy. Okay, so what's happening is the mechanical energy is going to remain constant. Okay, so there's no change in mechanical energy. All right, so which means that it's going to be conserved in this case, conservation of mechanical energy. So what do we have? Initially, it's going to be all potential, and then it's going to hit here. It's going to be all kinetic. This is going to go back up. Kinetic energy is going to go down, so it's going to turn into potential energy. So this is going to be our case number 1. All right, so we got observations. And this is our first case. Okay, so this is going to be the conservation of mechanical energy. All right, so the force acting on the system is going to be the gravitational force, which means that we are ignoring the surface friction. If gravity is the only force acting, so what happens? Mechanical energy is going to be conserved. All right, so no surprises here. Gravity, because of the gravitational force, initial and final mechanical energies are the same, which means that the mechanical energy is conserved. If there's a propulsive force acting on the system, then what? All right, so
Hoffman wanted to jump up to 30 feet. He couldn't build a ramp high enough, so he used a motorbike to tow him up to speed. Hoffman wanted to jump up to 30 feet.
It's exactly like the Galileo's incline experiment.
Hoffman wanted to jump up to...
Except notice that he ends up getting mechanical energy. All right, so he's going higher up, which means that he's getting mechanical energy. So the question is, where's he getting that mechanical energy from? So that mechanical energy must be coming from somewhere, right? Okay, so this time it's going to be our case number 2, which means that we have a propulsive force acting this time. It's not gravity. This time it's going to be a propulsive force. Again, it's going to be the same as the Galileu's incline experiment. All right, so we will start at a given point. And then, okay, let me just grab this because I'm going to use the same setup again. Copy this. Okay, so he's starting off right here. It's the same motion. And then he's going up further. Okay, so what that means is here's his initial mechanical energy. And here's his final mechanical energy. So what happened is he ends up gaining mechanical energy. All right, so which means that he gains mechanical energy. There's a difference between these two. So mechanical energy is gained. Okay, guys, mechanical energy is going to be gained, meaning that this energy is going to be larger than this, which means that mechanical energy is no longer constant. What that means is the propulsive force is not a conservative force. Gravitational force is a conservative force because there's no change in mechanical energy. Propulsive force is not a conservative force because the mechanical energy is no longer conserved. It's not constant. That's what it means. Okay, notice that this guy ends up getting mechanical energy. So the question is, where did the extra energy come from? I mean, the system, the mass is getting extra energy from somewhere. All right, so it's getting energy. It's getting the energy from somewhere, right? So what do you suppose it's getting its energy from? Okay, the short answer is it's going to be getting its energy from, it's getting from the engine itself, right? It's got a motor. It's getting it from the engine itself. Okay, so where's the engine getting its energy from? Oh, it's getting from the gas that you're putting into it, basically, guys. That's what you do. All right, it's using a propulsive force, which means that it's using some kind of combustion. All right, so the combustion engine is going to convert the energy into the extra mechanical energy that you're getting. All right, so the gas that you're putting into the tank, what kind of energy is that? It's called chemical potential energy, right? All right, so the gas that you're using, it's got chemical potential energy. Basically, this mechanical energy that you're getting is mechanical energy that you're gaining. It comes from the gas that you put into the tank, and the gas has chemical potential energy in it, which means that this structure, the chemicals, atomic and molecular structure, contains the energy within it. All right, so originally, obviously, you get the gas from a gas station, and the gas station is going to get it from a place that processes the gas. And that's the sort of gas that, it's petroleum, so you just dig it out of the ground. You can trace that to the original form. The original form, it just goes back to all the way back to the dinosaurs, right? Okay, so dinosaurs, where'd they get their energy from? They end up getting their energy from eating other dinosaurs as well as plant life, right? So where does the plant life get its energy from? It gets it from the sun. All right, so we end up getting it from the sun. All right, so in terms of getting it from the sun, all right, so what else did we get from the sun? We end up getting light. Obviously, we end up getting heat from the sun. All right, we end up getting light. We end up getting heat from the sun. So the next question is, where does the sun get its energy from? All right, so the sun ends up getting its energy from the nuclear processes that take place inside the sun, right? So what's happening inside the sun? The hydrogen fuses into helium, and the helium fuses into something else and something else. That fusion process, a nuclear process, is what generates this energy. So which means that nuclear fusion, nuclear energy turns into heat, and then it turns into light. Heat and light that we receive from the sun is what drives life here on Earth. And obviously, you got the chemical processes, the chemistry and biology or whatever. As a result, what happens is the motorcycle ends up gaining extra mechanical energy. So this extra mechanical energy that the motorcycle gains comes from chemical energy. It's going to be related to light. It's going to be related to heat, and then everything is driven by the nuclear fusion that takes place inside the sun. So what's fusing inside the sun? It's hydrogen fusing into helium, and that's what drives life here on Earth. So the next question is, where did the sun get its hydrogen from? All right, so obviously it gets it from space. Where did space get its hydrogen from? You can trace it all the way back to Big Bang. So this little bit of mechanical energy that you end up gaining can be traced all the way back to Big Bang. All right, so you end up getting mechanical energy through a combustion process that's going to generate a propulsive force that you're looking at. It can be traced all the way back to Big Bang. All right, so given the fact that all energy can be traced all the way back to Big Bang, the question is, guys, why are we paying for it at the pump? Which means that energy is free. Energy is free, so why not just fill out the tank and just drive away? And when you get arrested, make this argument to the judge. just say, hey, the energy that you're utilizing can be traced all the way back to Big Bang. Okay, so you don't want to pay for it because it's free. Okay, because of this energy which is generated from Big Bang, you become you, I become me, and we have this discussion, believe it or not. The next process of chemistry is going to turn into cellular structure, so it turns into biology, and somehow magically, there's something called consciousness kicks in, awareness. At the cellular structure, you become you, I become me, and we have this discussion. That's just the magic that no one really understands how that comes about. But the thing of it is, they literally, guys, the stuff that you're paying at the pump can be traced all the way back to Big Bang. So why are we paying for it? Paying for the gas at the pump, given the fact that it's free. I got news for you guys. The energy is free. You're not paying for the energy itself. It's free. Everything could be traced all the way back to Big Bang. You're paying for the processing. Somebody has to find it. Somebody has to dig it out. Dig it up. Somebody has to refine it. Somebody has to transport it. Blah blah. There's a lot of work involved. So you're paying for the service in essence. Okay. Somebody conveniently makes it available for you. Energy itself is free. Okay. So this propulsive force, when it's acting on it, what the propulsive force does, in essence, is converts the energy into mechanical energy. And mechanical energy is not conserved in this case when there's a propulsive force acting. So that was a weird story, but that's the way it is. Okay, so service and work to extract it, give yourself 5 points. All right, so that's what it is. You're not paying for the energy. Just remember that. People talk about free energy. Energy is free. It's been free forever. When I say forever, all the way back to Big Bang. We don't know what happened before that, but at least we have a rough idea, pretty damn good idea what happened after that. Except one of the things that we still don't know is, I mean, you go from chemistry into biology, question mark. Okay, so we have no idea where life comes from. Okay, that's one of the biggest mysteries. So all of a sudden, this consciousness thing kicks in. And it's just a mystery. It's a beautiful mystery, though. All right, so when there's a propulsive force acting, the propulsive force is not a conservative force, so we're done with that. What if there's friction? Then what happens? Okay, so Galileo, when he did the experiment, obviously the ball didn't go back up to the same height. He said, ignoring friction, the ball will go back up to the same height. All right, so ignoring friction, and Galileo said, ignoring friction, if gravity is the only force, everything is going to accelerate at the same rate. And ignoring friction, the ball will go up to the same height. What that implies is with friction, it's not going to go back up to the same height. So here's your initial mechanical energy. Here's your final mechanical energy. So which means that your final mechanical energy is going to be smaller than your initial mechanical energy. So what that means is the mechanical energy is going to be lost. So there's a loss of mechanical energy. All right, so there's a loss of mechanical energy. So here the mechanical energy is gained, and here the mechanical energy is lost. Okay. So when we say mechanical energy is lost, now we have to account for the missing energy. So all of a sudden, when you look at it, number one, you will realize that that mechanical energy, because of friction, there's going to be sound which is going to be generated. Okay, this thing is going to roll down, generating sound. So sound is a form of energy. So it's going to get converted into sound. Also, if you look at the temperature of the surface, this surface temperature is going to go up, which means that it's also going to generate heat. Okay, because of friction. And if there's too much friction, it can also turn into fire. The temperature is going to go so high that things will start to glow. So it's going to be light in the form of fire. That's what's going to happen. All right, so it's going to turn into sound, heat, or light energy. So these are forms of energy. And these are also forms of energy. Okay, so one thing that I want you to notice, there are two things that I want you to notice. Number one, gravity is a conservative force because mechanical energy remains constant. There's no change. Repulsive force is not a conservative force because you gain mechanical energy, so it's going to be larger. Friction is not a conservative force because you lose mechanical energy. Okay. In this case, the mechanical energy is gained. In this case, the mechanical energy is lost. Okay, so mechanical energy is going to be lost. Okay, so okay, so mechanical energy is going to be lost. Okay. When the mechanical energy is lost, it's not like the energy is destroyed. On the contrary, when the mechanical energy is lost, the energy is not destroyed. It just gets converted into something else. It gets converted into sound, heat, or light. Or when it's gained, it's not created. It gets converted from either chemical, light, heat, nuclear, or something along those lines. Okay, all of a sudden we notice that you can lose or gain mechanical energy, but the energy itself is not created or destroyed. What happens to energy is conserved. The total energy in the universe is still constant. That's what it means. So the constancy of energy is known as the conservation of energy. Okay, so when there's friction present, mechanical energy is lost. When there's a propulsive force,